Hi, everybody. Thank you for joining us on our second HolzChat, episode number 2. We are super excited about the guests and the content. This episode has been called Future Wooden Building Systems. The guests we have today are people that we are collaborating on with Stolz Timber on projects. We've got a great case study that we're going to go through. So let me just go ahead and tell you who we've got. We are first going to be speaking with Lucie Krbcová from Czech Republic. Lucie has been working for 7 years in the timber industry, first as a quantity supervisor, and later she co-founded a company which specialized in design and structural calculations of CLT buildings, and now for Novatop GSM in the USA, UK, and South Africa. Novatop, you're going to learn a lot about Novatop. They're a manufacturer of advanced wood products. We then have Blaas, who is the CEO of Rothoblaas USA. He works in Switzerland, UK, Canada, USA, and China to make Rothoblaas a leading supplier of special building materials and integrated solutions for the mass timber construction industry. And we also have from Rothoblaas, Muhaw, who is the technical representative of Rothoblaas USA for the Northeastern US. After 20 years within the medical device industry, he followed his passion for energy efficient buildings. Jim's a certified Passive House Institute envelope specialist and uses his business and technical experience to advance climate change through the use of more advanced wood products and low carbon buildings. And then we have returning from our first episode, our good friend Pat Clark, who's a mass timber pioneer based in Montana, co-founder of Stolz Timber Systems, which is bringing European mass timber technology and products to architects and builders in North America. So we're going to start out with a little product overview so everybody has a little better understanding about the amazing offerings and services and delivery of Novatop first, and then we'll talk about Rothoblaas, and then I think we're going to get into an awesome case study on a project that everyone worked on. Lucie, you have the stage.
Okay, so hello. I would like to introduce the Agrotnova company. Agrotnova company is actually the producer of the multi-layer solid wood panels and the producer of the Novatop system, a building system of solid wood. We produce the 3 plies out of 3 species, which is spruce, larch, and fir. And the Novatop system is mainly used mainly produced from spruce. Actually, the history of our company has started in 1992. That's when the 3 plies history started. And then the major owner was thinking what could be actually the next added value to the 3 plies. And during his visit in the Alps, looking at the houses, he got the idea, why not to build houses out of them? So the cooperation with the Swiss engineers started, and they developed the Novatop system. And in 2005, the Novatop construction elements production actually began. So these are just the basic numbers. So we definitely care about the nature. That's why we do our best to be in the harmony with the nature. And we are proud holder of the following certificates. The certificates Nature Plus is a prestigious international quality brand for building and furnishing products and it's related to the ecological production protection of limited resources. PFC is actually certification system for long-term forest management. CE is certificate that indicates conformity with health, safety, and environmental protection standards for products sold within the European Economic Area. And ISPM is actually the certificate to prevent the spread of disease and insects that could negatively affect the plant ecosystem. We definitely love the timber, the way it smells, the way it makes us feel, and we love to work with it. So that's why we are actually using it as the main material for our products.
Lucie, thank you. That was actually really helpful. I think now it helps us understand a little bit more about what Novatop does and can offer. I think we are going to move to Jim and Hannes and find out about Rothoblaas.
So hello, everybody. Thank you for taking time out of your day to join us. It is an honor for us to participate in this forum about engineered wood buildings and high-performance homes. There are both challenges and opportunities in this area of engineered timber, in our case today, and we at Rothoblaas will provide solutions to address those challenges with both product solutions and technical design experience. First, I'd like to introduce you to Blaas, who is our CEO here in the US, and myself, and also Rothoblaas to you. As you can see here at Rothoblaas, we are based in the South Tyrol region of northern Italy, where wood buildings are our culture. There's lots of opportunities for outdoor venture, skiing, hiking, and climbing. So if you're in the area, please come by and visit. You can also taste the wine in the local area, which is also a great opportunity as well. Rothoblaas has 30 years of experience in engineered wood timber buildings and in the construction industry as a building supplier. Our range of offering is structural connectors and fasteners, building envelope, acoustics, and technical design experience. Here at Rothoblaas North America, we've been established for 8 years, first in Canada, and a year ago, Rothoblaas USA was established. Along with myself and 4 other technical representatives, we are all based in the US with Hannes as our leader here in the US and in North America. And our American headquarters are in Vancouver, BC, where we have a warehouse and also our central operating location for North America. So here at Rothoblaas, we're always close to you no matter where we are. As you can see, we're very well established in Central Europe. That region is called the Silicon Valley of timber. We have presence in South America, also in North America, which is us, and then also in Australia, South Africa, and then also in the Far East. Here at Rothoblaas, there are 400 different collaborators or employees. We serve 80 markets, and we're close to 100,000 shipments out of our warehouse in northern Italy. And as it says here, we have an alpine heart and an international spirit. These are our core areas of competency, from fasteners and connectors to membranes and airtightness and waterproofing. We're also involved with acoustics and fall protection and personal protective gear. And then also we provide tools and machinery as well. These are the type of buildings that we get involved with across our building landscape, everything from multi-story timber buildings to timber frame buildings to log homes, and then also in outdoor structures. Most of the work here in North America has been on tall buildings, and those buildings are the most prominent that we all know about as far as mass timber. Here are some of the examples of those buildings that we know most outside Europe, Central Europe. But the real opportunity here is that in Europe, especially in Germany, a lot of the buildings that are built are low-rise. Here is a picture of Munich, where none of the buildings can be taller than Old St. Peter's Church here in Munich. So this gives us a great opportunity, even though here in North America we know mass timber mostly for its opportunities with large tall buildings. There really is an opportunity for low-rise and also single-family buildings, which is why we're here today. Some of these low-rise buildings are becoming great prominence. Future projects such as the Model C project in Boston is a multifamily building, 5 stories. It's an infill project. It's not a tall building. It's a building that is serving a purpose for multiple family and mixed use. We also know that there are large buildings, which is here, the Brock Common building in British Columbia. This was a notable building here in North America. It was a building that we learned an awful lot about. The material that is used in this building is the amount of material that is produced in Europe 300 times over. So on to this next slide. This is an example of the 300 Brock Common buildings that provide the amount of material in Europe on an annual basis. Those types of projects are not tall buildings. They're low-rise buildings and they're single-family buildings. And there's a great opportunity for us in North America to introduce this material to our residential single-family building world and also our low-rise building world. And Hannes, just want to pass it over to you to give a few comments from a European perspective, since you spend time there and you know the residential market more there than we do here.
Yeah, thank you, Jim, for that introduction. Yeah, so there's the thing in Europe is that mass timber has developed slowly over the last 30 years. The first mass timber panels, CRT panels, have been around since the mid-90s. And it was more of a bottom-up approach, contrary to what we're seeing in North America, where it's more of a top-down approach. So we see buildings we see more big buildings, and everybody's talking about the big buildings, and then it's starting to trickle down, while this movement into bigger construction in the English-speaking countries led also now to a upwards move in Central Europe. So we see positive influence. So we see both continents positively influencing each other. And an important factor for that trickle down into the residential and smaller construction market is that we have now a much more friendly environment for mass timber in general. And with friendly environment, I mean there is more awareness about it. Building codes start changing and be more open towards this new material. And also we have better supply chains, more options in experienced design firms, such as Pat and HolzChat system, and also standardization in the supply chain of hardware, for example, as Rothoblaas is doing.
What we've seen, what we typically see when we talk about mass timber is those, as you said, the high-rise building with all these solid panels that totally make sense on that scale, but there's a huge opportunity to actually move into the single-family area, and that's actually what started everything in Europe. As Hannes was saying, it kind of went the other way around, and that's something that together with these kind of systems that we just learned about, that we see as one of the future wooden building systems, because it has a lot of potential, because there are just a lot of it's a lot more fine-tuned towards single family, and single family can definitely benefit from all of this. And we actually we all pretty much worked on one project that Pat has built, and that's actually going to be our case study in talking about how process works, where again what we see from these mass timber presentations is typically the awesome pictures where everything just kind of fits together within a week or less. But there's definitely a lot of components and a lot of work that needs to go into it beforehand, so that all kind of works out like that. And that's what we want to talk about in this case study.
Yeah, actually, that's perfect, Ilka. I think what I'm really excited about this case study, and especially following up what we just learned about Rothoblaas and Novatop, is that what you never really see it as how does it actually all get done, right? I mean, what we always see are these buildings that just kind of seem to go from concept to boom. They're installed in rapid pace, but we don't actually get to see how do the assemblies get chosen, and who decides the connectors, and how do all those instructions get, you know, spread out and get to the right people? There's a ton that happens, and it takes a really good team. We're fortunate enough at Holtrum to be plugged in with some amazing people all over the world, and this project is just an absolute perfect example of a team working together to bring all the different perspectives and offerings into a delivery. Should we learn about Red Lodge?
So we're based in the northern Rocky Mountains. We are in Whitefish, Montana, the Flathead Valley of Montana. The region that we service is sort of maybe a 500 or 700 mile region, expanding around Flathead Valley. This project came to us. It was interesting because the client had a very clear concept of exactly what he wanted to build, but he did not have a design to start with. And what he was looking for was an integrated provider solution, somebody that could really hold his hand all the way through the process, from taking his design that was in his mind and realizing it in 3D and assisting him in figuring out the geometry of the building. So the location is in south central Montana. The location of Red Lodge is just northeast of Yellowstone National Park. To put it in perspective, the elevation is quite high there, over 5,000 feet of elevation. The dominant climate zone there is definitely winter. Temperatures can get quite cold there in the winter time, down to minus 40 Fahrenheit or minus 40 Celsius is not out of the question in that climate zone. So for sure, one of the things that we talked about in the very beginning stages of the project was thermal comfort. The client was keenly interested in all of the aspects of mass timber that can be readily produced, which are thermal comfort, low carbon construction, non-toxic products. He was very, very interested in carbon negative solution if possible. And then of course, because of the severe climate that Red Lodge is in, he was interested in having very few carpenters on site for a very short period of time to get the building constructed without weather delays. And what all of that meant was we had to plan this thing, and we had to really plan it in very, very minute details, right down to the millimeter, especially because of the shape of this building. It's an octagonal structure, which means it does not leave you a lot of leeway for errors when all of those corners come together. Next slide.
So Pat, I just wanted to say real quick that so the design process in general, besides the wish that, or the need that everything has to be put together really quickly, is fairly similar to a regular design process. But can you talk a little bit more about what makes this design process like really different?
I think the thing that makes this design process different from, say, standard construction methods is that we have to start with a 3D design immediately. We spend very, very little time in the two-dimensional world because these panels are going to be prefabricated in a factory setting. And so you have to very quickly arrive at what we call a massing model. And the massing model sort of shows the thicknesses of the panels and the beams and the overall shape of the geometry. But you have to proceed very quickly from that to actually specifying the specific panels and beams and materials that you're going to utilize. And with the unique thing with the Novatop system is that each product offering is optimized for the solution, or sorry, for the location or the position in the building. So the solid panels are specified for walls, both load-bearing and non-load-bearing. And the element panels, or as Lucie says, the cassettes, are specified typically for floors, and they allow you to place insulation or acoustic protection material into those assemblies. It's a closed box assembly, so any of the mechanical or electrical or plumbing solutions that you need to integrate need to be thought out ahead of time. They need to be modeled in 3D for all of the drillings that would need to happen and any materials that would need to be placed internally. So this means that not only are you designing the building as you go, but you're designing all of the assemblies, the sub-assemblies for the building, and you're designing them in a way that allows them to be cut on large format CNC machines. So you're thinking not just about the design and not just about the MEP, but also the manufacturing of the products in an off-site location, which in this case happens to be on the other side of the planet from us. So here we start to look at some of the assemblies of the building. This is the Novatop solid system, and in the center slide there you see the carpenters on site are doing some on-site prefabrication. And the reason for this is, you can see in the right-hand slide that the wall that has been pre-assembled on the deck of the building is much larger than you could actually ship from the factory on a container or on a truck. And so what we elected to do on site was do some on-site fabrication so that the walls could go in as larger assemblies. So it's just a sort of an example of a hybrid where you can't prefabricate 100% of the products in the factory due to size constraints, but with talented carpenters who understand the systems well, you can still utilize the rapid on-site assembly. So one of the major components of this project is, and this is not often discussed, I think this is a really important point. We hear a lot of talk about cross-laminated timber, glue-lam beams, large timber buildings. What is sort of lost in the discussion is the fact that there's a lot of building science that goes into making these structures comfortable, thermal comfort for winter and summer habitation. And our preference is to utilize wood-based materials, specifically wood fiber insulation. We use a company that's based out of Munich called Steico. And we also combine the Steico wood fiber products with the Rothoblaas fastening systems and vapor permeable membranes. And that's probably one of the most important points of this, is that the combination of the solid timber panels plus the insulation creates a vapor permeable wall and roof assembly that allows the vapor control of the building to progress naturally from the solid panel through the insulation to the exterior of the building without stopping the vapor flow. So we want that vapor to flow naturally through the building progressively from the inside to the exterior.
Hey, Pat.
Yeah.
So could you go back a slide, Ilka?
Mm-hmm.
So I just wanted to kind of point out that when you, on the Red Ledge project, you installed the the Novatop system, including the solid panels, which are CLT-like panels, and the other element panels. And then afterwards, there was basically a team of carpenters that sort of applied what we're looking at here, right? They layered it on pretty much piece by piece.
Correct.
And the reason I'm bringing it up is we'll talk a little bit about it later on, but what Holztrom System and Stolz Timber are working on is, again, trying to move as much of the fabrication away from the site, away from the risk of weather and skilled labor shortage and a lot of the other things that can kind of blow a project budget, and move things to the factory. And one of the things that we are looking at with Stolz Timber is a thermal skin. And so we're really excited because it's like a combination of having, Novatop and Rothoblaas and Styco and Stolz together with Holztrom System we're really making some big strides in getting this to be as much of an offsite fabricated full thermal structural envelope instead of just your standard CLT and now spend another month to basically wrap this thing. So go ahead.
That's correct. Yeah, I think that's super important. Everybody sort of gets really excited about the 4.5-day raising. They see the CLP structure go up. It's very exciting. And then things sort of go into first gear. They slow down a little bit, and everybody has to go back to the old way of manually applying all of these layers of products. And when we talk about future building systems, we need to not just apply the concept of prefabrication to not just the structural elements, but also to all of the elements of the building, and to harness the potential of the rapid crane assembly. So that's where this winter coat panel concept comes in, where the thermal envelope of the building could also be prefabricated and assembled rapidly.
Well, and then you can actually take it further, right? Because now you're going from the inside out, but you can actually look at it then going from, further to the inside, where are there more opportunities to apply that maybe to the built-in furniture or other elements within the structure. Like how can there be more that can get prefabricated and just kind of flat packed, craned into the room, and then assembled from there? And that's something where the 3-ply that Lucie was talking about earlier really comes into play as well, right? And actually on our next slide here is part of this wall as well.
That's correct. So on the left there you see the Novatop open panel system, where we are able to utilize a 3-ply panel on the backside of the vertical timbers that makes the immediate structure. But then on the inside of the panel, we're able to integrate the MEP products into the wall. And then, and ideally, those products are also designed ahead of time and prefabricated off-site and delivered in like a plug-and-play method. So there's no folks on the assembly site manually assembling those products. They're all assembled off-site because we have modeled everything, not just the panels, but also the mechanical, electrical, and plumbing. And then, as Ilka mentioned, the opportunity to CNC flat pack all of the components. So think about it like you're in a room, and when you're craning the building together, all of the pieces of that building that need to be in that room get craned into place, pulled out of the crate, and rapidly assembled. All of the design, all of the cutting, all of the drillings, everything is already completed. And rather than building it on site, we are assembling it.
Yeah.
So one of the advantages of the Novatop system is, as we discussed earlier, is that each position in the building, whether it's a floor, exterior wall, interior wall, roof assembly, each product is optimized for that location. And one of the things about a roof is oftentimes there's a lot of things that end up in a roof. Insulation ends up in there. A lot of fasteners end up in the roof assembly. We have to get the waterproof membrane on top of it. And then also the mechanical, electrical, plumbing guys, they need to maybe put roof vents through there, perhaps a chimney flue. There's a lot of things that have to happen inside of that roof. And so what the open panel does is gives us the opportunity to select the amount of work that we want to do, whether it be from the top side of the panel or from the underside of the panel. But it gives you an immediate surface to walk on. As soon as you crane the panel into place, you can immediately stand on it and work in the space, and then get your MEP solutions into the roof as quickly as possible, and then rapidly cover it with your thermal and your waterproofing. So wood fiber insulation, this is a product that not a whole lot is known about right now in North America. Oddly enough, it was a quite commonly produced product in North America up until maybe 40 or 50 years ago. And then at the time it was used mostly for like a exterior sheathing product, and there was a large number of wood fiber manufacturing facilities in North America. But with the advent of plywood and then eventually OSB, the utilization of wood fiber insulation as a sheathing material went out of favor. But in Europe, it's been gaining larger and larger amounts of market share, primarily because there's a deep concern for the energy consumption of buildings. So everybody was moving towards adding more larger amounts of thermal insulation to the exterior walls, the roof, even interior floors, interior walls. But not only were they looking to drive towards more amounts of thermal protection, but also wanted to do it in an ecologically correct way.
So Pat, at this point, we pretty much had to decide how much of this insulation we need, right? What are the assemblies exactly? So, and Pat asked us at HolzChat System to do some energy modeling, and the client was very much on board with that. So what we did is we actually set up, I think at the end we had like 6 different cases on trying to see how much insulation, what do the assemblies actually really look like. And for me, when I did the energy modeling, what was interesting is I've done a lot of energy modeling, but not in that climate. So for me, just kind of, jumping into that climate was just very eye-opening. There's basically no cooling loads, which is crazy. And then the other thing too is for me working with CLT was different as well, because what you can see here in this one case, this is all measured against passive house standards. So we're not really kind of meeting, I mean, we're really good, but we're not meeting those standards yet. And we had a lot of conversations, Pat and I, where Pat was saying, isn't there a setting in Woofy that really just kind of takes all the thermal mass into consideration? And there is one little button. You have like 3 choices, but it doesn't really do a whole lot. So that really kind of made us think, because Pat kept saying, well, out of experience, I know being in those buildings, it just feels different. It stores the heat differently. It just feels different than being in a stick-built building. So, and what's really interesting or really cool is that we started talking to one of our future guests, Florian Antretter. He is one of the developers of Woofy. And we actually asked him those questions. How do you really calculate it? Does it make a difference? Is that something that should be calculated when we look at those buildings? And we also asked him about the whole concept of phase shifting that Lucie was talking about earlier on. And yeah, we'll be excited to continue that conversation on one of our future HolzChats. So we're excited about him coming on. So Yeah, I guess now we kind of got to a point where the panels were selected and assemblies and all of this, and yeah, how does it all fit together? So that's pretty much the next thing that we want to talk about. How do the panels then get connected?
So we've been working with Rothoblaas since I think 2010, and it's taken a fair amount of research on my part to understand the systems. And now what's extremely positive is Rothoblaas has now put their foot forward into the USA marketplace, and we are opening up, as Hannes says, we're opening up the supply chain for North America, which means that now it becomes much easier for this whole team of designers and integrators for these projects to utilize the the brain power of Rothoblaas, and we work directly with them by sharing our design and our models, and then we rely heavily on them to recommend the correct products for each individual connection or assembly in the building. And maybe Hannes or Jim could just speak a little bit about how that process works from the Rothoblaas side.
These, there's many different ways that you can put these buildings together. There's fasteners, which is a purely screw fastener connections. But then as we evolve and as we get this trickle down from other solutions that we've developed, there's other ways to do the connections. So this is actually a collection of screws and also plates, angled plates, and also timber connectors that we have of different capabilities and different install capabilities. And you can you can look at these solutions and decide whether it's all going to be, it all depends, right? So are you going to be assembling as much as possible in a fabrication shop? And as Pat said, then the execution is just assembly. Or are you in a situation where you need to assemble or do your fabrication on site a little bit more? And what kind of options do you have there? Which in the case of Red Lodge, they did. So as the the project kind of unfolds based on its location, based on its material, based on how much you feel that's going to need to be done in a fabrication shop, you can select your components for putting this together. So so this is just what we call simple common solutions for timber construction for homes, and they're simple. They're not very complicated. And as Ilka said, that we can do a lot of this in the fabrication shop, even to the point where we're actually pre-drilling for our screws. So on site, all you have to do is take this connector with these screws and attach it. Now, in the next slide, we get a little more complex, where these are solutions for taller buildings, but they can also be used in residential construction as well. So the image on the left-hand side there, with the gentleman up on top of the CLT, is a purely really fabricated in a fabrication shop, where the panels then are flat packed to the site and then craned into position. The crane is actually, the hardware there is actually allowing them to crane it into position very quickly, and then it's all just bolted together, just more or less like Tinker Toys. The middle shot there is a column connector, more application for taller buildings. But then the connector, the column support on the right-hand side, that could be used in a residential home. So there's many different ways that we can address construction.
So yeah, I guess the next step would be, now that we know what the panels are, what the assemblies are, and how they get connected, how does it actually get communicated to the, first of all, how does it get built in the, by the manufacturer? How does everything get communicated there to the machines, pretty much? And then also, what kind of instructions are there for the people on site to actually put it all together? So I don't know, I guess Lucie, you wanted to talk a little bit about the process of the shop drawings and what it does in the factory.
Basically, first, we get the IFC 3D model from Pat. Then the second stage is that we get it discussed with our structure engineer, and he sets and confirms the dimensions and the main issue of load-bearing areas. And then according to his calculations, we get the design started for the production. And also, hand in hand with that go the details. So he specifies what kind of ankle anchors and what kind of fasteners should be used, in which positions and in which amount. So it actually all comes from him, these informations. And out of this information, they are able to make the list of the material that is used for the construction to actually put all the building together. And then also we get the details that need to be like pre-machined, not only for the Novatop system, but also for the PSH and KBH details. So we can get all those details according to those drawings pre-machined as well. Basically, the communication with the production is in between 2D and 3D, 2D drawings and 3D models. And thanks to this communication with Patrick, structure engineer, and the production, we all made it work. Definitely, we had to focus on the limits that we were given by the transportation. Yes, because the limits that the container dimensions gave us were very important for the logistic of loading, unloading, and transportation, and preparation on site for the mounting crew. And I have to say it worked really amazingly, and it was very helpful to have Pat on site with a 3D model, so everyone could see all the time not only the 2D drawings that we had printed, but also the 3D model with all the details, how it was connected, and it just worked beautifully.
So Pat, do you want to talk a little bit more about the 3D model on site that was helping everyone to assemble? And then I have a question about who actually raised the building. Was that people coming from Novatop, or were those people that you hired in Montana?
Sure. So just to address the global logistics, it can seem like an insurmountable task to have a building prefabricated, say in Czech Republic or Austria or Germany, and delivered around the world. But to be honest, as long as you're accustomed to the concept of handling large, bulky, heavy materials, and you're prepared for it ahead of time, it can go remarkably quick. Like, you're looking at a 40-foot long container there that contains 20 tons of wood, and we pulled that entire package out in about 30 seconds and delivered it to a temporary logistic staging center, maybe in 30 minutes or so, that went from coming out of the container into a safe place to store. And then the goal is to integrate with local carpenters or builders we do not intend to be the builders of the houses. We are the manufacturers and the suppliers of the structural thermal envelopes. And the key to success is to have carpentry firms or Zimmerman who are capable of understanding how to handle these materials safely and quickly and efficiently. And one of the unique processes that we're working with is we train the building teams and the carpenters how to view the 3D model, and we set up a series of scenes inside of the 3D model so that they are able to study the building ahead of time, layer by layer and product by product throughout the building, so that they understand when we arrive on site with these assemblies exactly where each and every panel goes, what position it is in the building, what type of fastener will be utilized at each and every location, how we will lift each individual panel, what they weigh, the size of the panel, the length, the width. Are there any internal components, say steel or LVL, that we have to be aware of for fastening? And examine each and every component of the building in minute detail ahead of time, so that when we arrive on site, we're able to raise the building really quickly. And in this case, we worked with a very competent local builder in Red Lodge. The company is called Palisades Builders, and the owner is Adam Quick. And the remarkable thing, this was his very first mass timber project, but by being able to integrate with the entire team and understand the structural, the fastening, the thermal aspect, how do we mount the fenestrations, the windows, the doors, how do we make the building airtight? We studied all of that ahead of time, like a CLT university program. And when we got to site, there wasn't really a lot of discussion about how it's going to go together. It goes remarkably well on site. And in this case, we utilized multiple personnel. So Wooden House Supply sent 2 technical representatives to the site, including myself. Novatop sent 2 trained Czech carpenters to come to the site to assist us and train our North American builders. And then Palisades Construction had their team there as well. And the goal is that everybody gets training in the proper methods to realize these buildings, so that the next time it goes a little bit easier, and then a little bit easier each time.
Okay, that's great. So what kind of comes out of this, even talking about, taking this even a step further into how can even more be pre-manufactured or more assembled beforehand, if it's fasteners or flat packed packages for furniture or whatever, is pretty much the one basic key to all of this working is having what we call a high fidelity model for this building, right? Because everything has to be modeled pretty much 100% to the millimeter in order to really kind of make it all work. It has to be modeled to feed the machines, to really kind of do everything precisely in these manufacturing facilities. And it's just what you have to do in order to have a successful project. So what we kind of took from there, as talking to Pat and mainly Steve and I as Holzraum, is we came up with this model that we call single integrated manufacturing model, because we're seeing this huge, this kind of work that has to go into this kind of building, but there's also a huge opportunity to take that a lot further to really make it worth it. Steve, do you want to talk a little bit more about this?
There we go. So yeah, so this is an example of what we call SIM from a project that we recently did with our light frame Holztrom system envelope in Pennsylvania, and the way that we developed this was that we, like Ilka said, for offsite manufacturing, which is pretty much what Holztrom supports, which could be light framed, or it also could be these amazing Novatop systems. You need a model just to manufacture it, right? So you need a model, and then if we step back, you need a model to deliver the design intent to the factory. And there's a lot of steps in between. And what Ilka and I developed we realized pretty early on with these models was that there's so much opportunity, because you need that high fidelity model. There's so much opportunity to really explore and specify, like, how is the MEP going to run through it? How are up in the top corner right, how are some of the intricate millwork finishes going to interact with the panels when they come on site? How are the interior finishes, like components like timber framing and flat pack that Ilka mentioned earlier, millwork, cabinetry, all of these things. There's so many different parts that can be explored and really coordinated in a completely new way. So with Ilka, when we started working with Stoltz Timber, we got really excited, because now combining the SIM modeling process allows us to bring Passive House in. It allows us to, and now bring products like Novatop and Rothoblaas in all of these products that are already sort of built on a 3D modeling discipline. Now we can bring them into our models, and it seems like every 6 months there's even a larger library of IFC content, 3D smart. So IFC content is 3D objects that actually have data attached. So now we can not only model them and create shop drawings and raising and installation drawings, geometry checks for architects and clients, but we can also we can quantify and harvest data off of the models, including lists for parts, energy modeling parts, pricing parts. Like you basically start to create this really intelligent model that because it's in a single source, it's very safe for us. There's not multiple versions around, and we can create something that we can now, as Holztrom, we can service Pat, we can service Lucie and Hannes and Jim, and say, these are the parts we think we want. Is there something we're missing? Do we have the right application? Is there a new improvement of the part? Do we have the quantities right? Does it make sense for us to tell the model that's a part that's going to be installed in the factory, or that's a part that's going to be installed in the field? We have the control over all these things. So now we've taken this really powerful team of providers, and we're attaching the people to the model. So that's kind of what SIM is.
Yeah, and we kind of see, that together with all the developments that everyone else is working on as the future opportunity, and really just having to work together. And that's a platform that makes that possible. Hannes, what do you think? Because you're the master of little 3D clips on your side.
Yeah, I think that's great, especially when we're talking about takeoffs and material lists, because we see that is still something that the responsibility on that gets pushed around to different project partners, and also we are asked to do takeoffs, but we're usually not so deeply involved in the project, and that we know all ins and outs of the project. And then people could say, you counted too many, you oversold me, or you counted too little, and now you have to send me more product for free or whatever. It's very hard to get it right for us, and so that if it's done in a digital way, and we see more, and this is the way we have to move to. A lot of people are talking about it, and it's great that some people start doing that.
Yeah, thank you, everyone.
Thank you.
So this pretty much concludes our pre-recorded session, but we are switching over to our live session pretty much right now. So anyone can ask questions in the chat, and yeah, we'll do our best to answer as many as we can.